They didn't have computers, no steel, no electricity, but they built wonders we still can't explain today. From earthquake-proof cities to machines that ran on steam. Ancient engineers weren't just builders. They were visionaries who bent the rules of nature. Keep watching because number 10 will absolutely blow your mind. Number 1. The Egyptian pyramids poured, not carved. You've seen the documentaries, you've heard the theories, endless rows of slaves dragging stone blocks under the hot desert sun, building the pyramids one back-breaking inch at a time. But what if that's all wrong? A controversial theory gaining traction among scientists and archaeologists suggests something mind-blowing. The Great Pyramid of Giza may not have been built block by block but poured like concrete. French materials scientist Joseph Davidovits, after years of study, proposed that the Egyptians weren't quarrying millions of heavy stones. Instead, they may have molded geopolymer blocks using a recipe of crushed limestone, clay, lime, natron and water. This mixture would have produced a kind of liquid stone, which could be poured into wooden molds directly on site. But is there proof? Microscopic analysis of certain pyramid blocks has revealed trapped air bubbles, amorphous minerals and chemical signatures not found in naturally formed limestone. In fact, some stones appear to be a composite, containing fossil shells and debris in unnatural arrangements. Even stranger, ancient Egyptian paintings and carvings depict workers pouring materials into containers or molds, not chiseling massive stones. Now think about this. If you could pour stone into any shape, you wouldn't need ramps, pulleys, or an army of 20,000 laborers. You'd just need chemistry, molds, and sunlight to dry it. Some modern engineers have replicated this method and found it's faster, easier, and stronger than traditional stone cutting. It also explains how the Egyptians achieved perfect block alignments and tightly packed seams without visible tool marks. So what if we've misunderstood the most iconic structure in history? If the pyramids were made using ancient chemistry rather than brute force, then Egypt's engineers weren't just brilliant architects. They were the earliest known materials scientists, working with formulas lost to time, and knowledge that modern science is only beginning to rediscover. Number 2, the Roman concrete that heals itself. Today we pour concrete everywhere, bridges, highways, skyscrapers, but within decades it cracks, weakens, and crumbles. Repairs cost billions. Now consider this, Roman concrete, poured 2,000 years ago, is still standing. In fact, some Roman harbors have been underwater for centuries, and they're getting stronger. So what was their secret? Unlike modern concrete, which uses Portland cement and gravel, the Romans mixed volcanic ash, lime, and seawater. The volcanic ash, especially from Pozzuoli near Naples, reacted chemically with seawater over time. The result? A rare mineral called aluminous tobermorite, a crystalline structure that fills in cracks, resolidifies the material, and prevents corrosion. In other words, self-healing concrete. Modern researchers were stunned. When they analyzed ancient Roman samples in 2017 under electron microscopes, they saw something our concrete doesn't do. It grows new minerals inside fractures. One of the most mind-blowing examples is the Pantheon in Rome. Its dome is still the largest unreinforced concrete dome in the world, 43 meters wide. No steel, no internal framework, no repair in nearly 2,000 years. It's still perfectly intact. But here's what few people know. Roman engineers used different concrete recipes depending on the structure. For example, walls near the base of the Pantheon contain denser aggregate, while the upper dome uses lighter volcanic pumice to reduce weight. They even layered the mix for optimal strength and balance. And yet, when the Roman Empire fell, their concrete recipe was forgotten for over 1,000 years. Only now are scientists and engineers trying to reverse engineer it, hoping to design modern buildings that can last for centuries like theirs. Think about that. A 2,000-year-old harbor in Italy is more durable than most of our parking garages today. The Romans weren't just great builders, they were visionary chemists, mixing volcanic geology and architecture in a way we still don't fully understand. And it's a reminder, sometimes the future of engineering lies in the ruins of the past. Number 3. China's Grand Canal and the Zero-Pump Miracle. The Great Wall is China's most famous ancient structure, but the Grand Canal might just be its most ingenious. It's the longest man-made waterway in the world, stretching over 1,100 miles. That's longer than the distance from New York to Miami. But here's the kicker. Parts of it were built as early as 500 BCE, before the Roman Empire existed, and it connected the economic heartlands of northern and southern China like a liquid superhighway. It moved more than goods, it moved culture, power, and people. But let's talk engineering. Here's the challenge. How do you transport water across varying elevations, hills, and river valleys without pumps, motors, or electricity? Chinese engineers solved it with something almost magical: the inverted siphon. Instead of lifting water, they used gravity and pressure to force water downward through sealed, U-shaped tubes beneath an obstacle like a road or river, and then back up the other side. It was an early application of hydraulic pressure systems, centuries before Europe would understand the concept. And here's the wildest part: they used stone or ceramic piping sealed with natural gums and plant resin to maintain watertight pressure underground. Many of these inverted siphons operated flawlessly for hundreds of years, without any moving parts. But the innovation didn't stop there. The canal had locks and sluice gates to regulate water flow, stone-paved embankments to prevent erosion, and floating post offices to deliver imperial messages. One ancient account describes a canal boat traveling from Hangzhou to Beijing in just 20 days, unheard of at the time. And yet this masterpiece isn't ancient history. It's still in use today. Modern engineers have expanded parts of it, but the original framework remains intact, more than 2,500 years later. It's not just a waterway, it's a living system, powered by gravity, refined by observation, and engineered to last through dynasties. When you think of ancient China, don't just picture dragons and palaces. Picture a hydraulic machine the size of a country, built before the West even knew how to make aqueducts. Number 4. India's stepwells, ancient coolers and cosmic clocks. They're hidden in deserts, sunken into silence. And if you've never heard of India's stepwells, you're not alone. These aren't just staircases to water. They're a fusion of architecture, science, art, and astronomy that goes back over 1,500 years. In arid regions like Rajasthan and Gujarat, stepwells were a brilliant response to a brutal problem: how to access clean water year-round in places where rivers dry up for months. The solution? Dig deep into the earth and build a temple-like structure in reverse, with hundreds of intricately carved steps leading to an underground water table. But here's where things get extraordinary. These wells weren't just water sources, they were natural cooling chambers. The deeper you descend, the cooler the air becomes. At the bottom, temperatures can be 10 to 15 degrees Celsius cooler than above ground. Villagers use them as gathering places, markets, meditation zones, and even temples. Still, there's more. Some stepwells, like Rani Ki Vav, are decorated with thousands of sculptures, avatars of Vishnu, celestial dancers, and mythic guardians. Each figure was carved not just for beauty but to tell a story, layered through time as visitors descended closer to the water, both physically and spiritually. But perhaps the most mysterious feature is their cosmic alignment. Many stepwells are precisely aligned with the solar calendar. On certain days, like the summer solstice, the sun's rays shine directly to the bottom of the well, illuminating carvings or central altars for just a few moments each year. It's a solar clock, coated in stone. Engineers, astronomers, and spiritual leaders worked hand in hand to create structures that were functional, philosophical, and eternal. Today, many of these stepwells are abandoned or forgotten, buried under centuries of dust and neglect. But when restored, they reveal something stunning. Ancient India didn't just build to survive. They built to transform time, space, and spirit into a single, flowing form. Stepwells weren't just infrastructure, they were timeless machines powered by sunlight, water, and human wonder. Number 5. The Baghdad Battery Electricity from Clay. You're walking through the ruins of ancient Mesopotamia near modern-day Baghdad. The sun's blazing, the sand is silent. Suddenly you stumble across a clay jar, small, simple, cracked with age. Inside, a copper cylinder, an iron rod, traces of acidic residue. To the average eye, it's just pottery. To a curious mind, it might be the world's first battery. This unassuming relic, now known as the Baghdad Battery, has baffled scientists since it was discovered in 1938. Its structure is shockingly familiar. A clay pot as the casing, a copper sheet rolled into a cylinder, an iron rod suspended in the center, and traces of vinegar or grape juice, mild acids that can generate electricity when these metals react. Modern scientists tested replicas of the battery using lemon juice or vinegar and confirmed it produced around half to 1 volt of electricity. But here's where things get weird. Multiple similar jars have been found, not just one. And nearby, archaeologists uncovered plated metal artifacts, thin layers of gold fused to silver surfaces. Could these ancient engineers have used the battery for electroplating? It's possible. Electroplating, using electricity to bond a metal layer onto another, wasn't discovered in modern science until the 1800s. but the Baghdad Battery might suggest that they were doing it nearly 2,000 years ago. Others think the battery was used in rituals, giving priests the power to deliver electric shocks, divine lightning from the gods. Still, some dismiss the theory altogether, calling it coincidence. But here's the deeper mystery. If they knew how to generate electricity, what else might they have done with it? Light sources? Pain treatment? Was this part of a larger forgotten science or simply a one-off experiment lost to time? We may never know, but the Baghdad Battery forces us to reconsider everything we think we know about ancient intelligence. Because if a clay pot from 200 BCE could generate a current, then the history of electricity may have started 2,000 years earlier than we were taught. Keep watching, because the next 5 inventions will shake your idea of ancient civilization even more. Number 6, Rome's Cloaca Maxima, the city beneath the city. We praise the Romans for their roads, aqueducts, and grand arenas. But the greatest reason Rome didn't fall apart from the inside? It flowed beneath the streets, in silence, in shadow. It was the Cloaca Maxima, one of the oldest and most sophisticated sewer systems in human history. Built around 600 BCE, long before the Colosseum or the Pantheon, the Cloaca Maxima was originally a canal to drain marshes from the site of the early Roman Forum. But over centuries, it evolved into something extraordinary. A vast underground drainage network that managed storm runoff, wastewater, and public sanitation in a city of over 1 million people. Let that sink in. While much of the world still dumped waste in the streets, ancient Romans were using gravity-powered sewer technology to keep their capital clean. But here's the twist few mention. The system was integrated. Public toilets, fountains, kitchens, and bathhouses were all connected to this hidden network. Inspection shafts were built into the design so workers could descend and clean blockages, just like modern maintenance tunnels. The flow was regulated using stone-cut slopes and water diversion gates to manage pressure and prevent backups. And it wasn't just functional, it was built to last. The Cloaca Maxima was made of carefully cut stone and volcanic cement, some of the same material that makes Roman harbors indestructible. In fact, some parts of this sewer system are still functioning today, over 2,600 years later. Now ask yourself, how many modern cities can say the same? In a time when most urban centers drowned in their own filth, Rome's engineers had already solved the problem centuries ahead of anyone else. They understood that water, waste, and engineering weren't separate. They were part of a living system, and by managing the flow of water beneath the city, they helped keep order above it. The Cloaca Maxima wasn't just a sewer, it was a lifeline, an unsung masterpiece of civil engineering. Buried in darkness, but vital to an empire's survival. Number 7, the Maya's invisible water filter. Deep in the jungles of Guatemala, the mighty temples of the Maya civilization rise above the trees, testaments to their mastery of astronomy, architecture, and art. But their most brilliant achievement? It wasn't built into the sky, it was buried underground. In the ancient city of Tikal, archaeologists uncovered a secret hidden for over 1,000 years. A water purification system so advanced, it stunned modern scientists. In reservoirs that once held drinking water for tens of thousands of people, researchers discovered layers of quartz sand and crystalline zeolite. Now, zeolite isn't just any rock. It's a volcanic mineral with powerful filtration properties. It can remove bacteria, heavy metals, and toxins, and is still used in modern water filters today. Here's the shocker. Zeolite wasn't formally identified and used for water purification until the 20th century. Yet the Maya were using it in circa 200 BCE. How did they know? Some scholars believe they tested materials experimentally, observing how water flowed cleaner when passed through volcanic gravel. Others think the knowledge was inherited from earlier Mesoamerican civilizations whose wisdom was lost to history. Either way, this system wasn't accidental. The filtration layers were deliberately placed, and their presence has been confirmed across multiple reservoirs in Tikal. This wasn't just about convenience, it was about survival. Rainwater was the city's only water source. With dry seasons lasting months and stagnant pools ripe for disease, purifying their reserves was a matter of life and death. And while European cities in the Middle Ages were drinking sewage-infested water, leading to plagues and death, the Maya were sipping from volcanically purified pools, engineered centuries earlier. It forces us to rethink what we consider modern. The Maya weren't just builders of pyramids, they were environmental engineers. They understood geology, chemistry, and public health in ways that even today's urban planners are rediscovering. In the end, their legacy isn't just carved in stone. It flows in the silent, filtered waters they left behind, clean, deliberate, and centuries ahead of their time. Number 8. Indus Valley Plumbing, the first indoor bathrooms. Imagine a city with wide, straight streets, organized neighborhoods, standardized bricks, and houses with indoor plumbing. You're not in New York. You're not in Rome. You're in Mohenjo-Daro, a city from the Indus Valley civilization thriving around 2600 BCE. While much of the world lived in huts and chaos, the people of Mohenjo-Daro and Harappa were living with urban planning that rivals our own. Every home, rich or poor, had access to a drainage system. Bathrooms were built with sloped floors, leading wastewater to covered street drains made from kiln-fired bricks. Even more impressive? The sewers ran under the city streets and were wide enough for maintenance workers to climb into. They included manholes, inspection chambers, and even flushable latrines, thousands of years before the modern toilet was invented. These weren't crude holes in the ground. Some toilets had ceramic seats and water channels brought in clean water to carry waste away, possibly with a bucket flush system. And they didn't stop there. Their great bath, a massive public water tank, was sealed with natural tar to prevent leakage. Steps led down into the pool, which had inlet and outlet drains, suggesting that water was circulated, filtered, and drained regularly. Let that sink in. 4,000 years ago, the Indus Valley people had already designed public sanitation systems that would not reappear in the Western world until the 19th century. Meanwhile, in ancient Europe, even royalty relieved themselves in chamber pots dumped out the window. The builders of Mohenjo-Daro didn't leave behind pyramids or ziggurats. They left behind something quieter, but far more telling, a civilization obsessed with hygiene, efficiency, and equality. And the most haunting part? We still don't know what they called themselves. Their writing remains undeciphered, their language unknown, and their rise and fall mysterious. But their plumbing, it speaks louder than words ever could. They weren't just building cities, they were building the future of how humans should live, clean, organized, and connected. Number 9. Hero of Alexandria, the forgotten father of robotics. In the 1st century CE, deep within the scholarly heart of Alexandria, Egypt, lived a man whose ideas were so advanced, we still haven't caught up. His name was Hero of Alexandria, and he may have been the first roboticist in human history. Forget gears and pulleys. Hero built machines that could move, react, and even think, by ancient standards. Let's start with his most famous invention, the eolipile. It was a hollow sphere mounted on an axis with bent tubes at each end. When heated with fire, steam built inside and shot out of the tubes, making the sphere spin rapidly. In other words, Hero invented the world's first steam engine, 1700 years before the Industrial Revolution. Now imagine if the world had paid attention. But he didn't stop there. Hero also designed coin-operated machines that dispensed holy water when a coin was dropped in, a prototype vending machine, automated temple doors that opened when fire was lit on an altar using air pressure and counterweights, creating the illusion of divine power, mechanical theaters where puppets moved, music played, and curtains dropped, entire performances powered by water, air, and hidden mechanics. All this in the 1st century. But why didn't Hero's machines change the world? Historians believe the ancient world saw these devices as curiosities or religious wonders, not practical tools. Without mass production or industrial pressure, there was no drive to scale them. Hero's books survived for centuries, copied, studied, and hidden across Europe and the Islamic world. In fact, Leonardo da Vinci referenced Hero's work 1400 years later in his own mechanical drawings. Now pause for a moment. What if the eolipile had powered chariots? What if temples led to turbines? Would we have had electricity in the Middle Ages? Hero's world wasn't ready, but his vision, a world of automation, of machines that respond to fire, pressure, and coins, was a preview of the future. He wasn't just a tinkerer, he was a time traveler trapped in ancient Rome. Number 10. The Inca's underground masterpiece. Towering at 8,000 feet above sea level, nestled in the jagged peaks of the Andes, sits one of the most breathtaking sights on Earth, Machu Picchu. But what most visitors see, the stunning stone terraces, temples, and panoramic views, is only half the story. The real genius of Machu Picchu lies beneath the surface. What few realize is that 60% of the city's engineering is underground. Why? Because the Incas weren't just building a city, they were building against nature, on an earthquake-prone mountain where landslides and floods could strike without warning. Their answer? A hidden network of substructures, layers of porous gravel, crushed stone, and compact soil to absorb rain and reduce pressure. Drainage tunnels that carry away water from heavy Andean rains. Capillary channels, tiny slits carved into stone that pull water away silently, like the roots of a tree. It's called capillary drainage, and modern engineers still struggle to replicate it as efficiently. In fact, scientists estimate that Machu Picchu's drainage system diverted 60% of all rainfall, without concrete, rebar, or pumps. The city breathes with the mountain, flexing and shifting during quakes without collapsing. But here's the wildest part. The Incas had no written language. They engineered this with oral tradition, practical observation, and intergenerational trial and error. They worked with nature, not against it. And even today, Machu Picchu stands strong, while modern structures made of steel and glass crumble under pressure. Their engineering wasn't flashy, it was quiet, respectful, and astonishingly effective. They didn't just build a city in the sky, they built a living machine, a self-regulating, earthquake-resistant, water-managing miracle carved from mountain stone, and that's the final lesson of ancient engineering. It wasn't always about height, size, or gold, it was about harmony, endurance, and understanding the land itself. The ancients didn't have electricity, AI, or digital tools, but they had patience, genius, and a deep respect for nature's laws. They weren't just builders, they were visionaries, creating machines, cities, and systems that rival even our smartest tech today. So the next time you hear the word primitive, remember, some of the world's greatest innovations weren't born in the future, they were buried in the past. If you learned something new today, hit that like button. Subscribe for more epic true stories that challenge everything you thought you knew about history. And tell us in the comments, which ancient engineer impressed you the most? We're just getting started.